This is your May 6th math video. So this morning we're going to start talking about the repeating decimals, the cool decimals that I was showing you that will just go on and on forever. This is the official lesson date for that. All right, so let's begin with, so first of all, when we have like the fraction 1/4, and we're turning it into a decimal, we would say 1 divided by 4. So 1 divided by 4, and this is where we annex our decimal points and zeros. We would say 4 goes into 10 2 times. How about 2 times in the quotient? 2 times. 4 times 2 is 8. We subtract. 10 minus 8 is 2. We annex a 0 and bring it down. And 4 will go into 20 5 times. And 4 times 5 is 20. When that decimal is done, and when we don't have a remainder anymore, we don't have to annex any more zeros, we say that that decimal is terminated. Terminated means it's done, it's finished, it's over. So that is what the decimal is when we have no more remainders or no more zeros to bring down. It's terminated, okay? But if we look at this problem, if we look at 1/3, we have 1 divided by, our fraction bar is divide, 1 divided by 3, it would look like 1 divided by 3. We're going to put our decimal up there and annex our 0. So how many times will 3 go into 10? It'll go in there 3 times. Let me erase that just so it doesn't run together. 3 times 3 is 9. 10 minus 9 is 1. We annex a 0 and bring it down. How many times will 3 go into 10? 3 times. 3 times 3 is 9. We subtract. We have 1. We annex a 0 and bring it down. 3 will go into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. So do you see what's going to keep happening here? We will forever put 3 at the top. 3 times 3 is 9. 10 minus 9 is 1. Bring us annex a 0. It'll just keep going on and on and on forever. So our answer for 1/3 as a decimal, 1/3 equals, we put 0.3 and we put a line over it because that 3 is going to just keep repeating and repeating and repeating and repeating. Now it also can be written 0.3 ... but we're not going to do it that way. We're going to write it 0.3 with the repeating line over the digit that is repeating, because in some decimals and some of the problems, not just there'll be different, I'm trying to say this. There'll be more than one digit in the decimal, but possibly only one digit is going to be the repeating decimal. So you have to put the line over just the decimal that is repeating. So let's go ahead and look at, let's do 5/6. So we have 5/6, or 5 divided by 6. Okay, so we'll put our zeros. How many times will 6 go into 50? Well, 8 times 6 is 48, so we're going to put 8 up there. We subtract. 50 minus 48 is 2. Okay, so we're going to annex a 0, bring it down. How many times will 6 go into 20? 6 will go into 20 3 times. 6 times 3 is 18. 20 minus 18 is 2. We're going to annex a 0, bring it down. How many times will 6 go into 20? 3 times. 6 times 3 is 18. 20 minus 18 is 2. We're going to annex a 0. Do you see the pattern here? Bring it down. 6 times 3 is 18. And we could sit here and do this all day, and this decimal would never terminate, because which digit is repeating itself? The 3 is repeating itself. So 5/6 equals 0.83 with just the 3 repeating itself. So our line won't go over just the 3 in that answer because only the 3 is repeating itself. Okay, makes sense? Now let me show you one more. Remember, if the decimal finishes and we don't have to keep indexing zeros, it terminates. You will start seeing that word in your directions. It will say, turn the fraction, just like in my own words, turn the fraction into a decimal, into a decimal, a terminated decimal is how it says it, I think, in the directions. So you will start seeing that word in your directions, and that just means you keep going until there's no more zeros to bring down, until there's no remainder. All right, so the last one I want to show you is 3 11ths. So this will be 3 divided by 11. Okay? All right, so how many times will 11 go into 30? Well, it'll go in there 2 times. 11 times 2 is 22. We subtract. 10 minus 2 is 8. So we annex a 0, and we bring it down. How many times will 11 go into 80? 11 will go into 87 times. 11 times 7 is 77. We have 3. We annex a 0. We bring it down. How many times will 11 go into 30? 2 times, that hasn't changed. 11 times 2 is 22. We subtract, we have 8. We annex another 0, and we bring it down. How many times will 11 go into 80? 11 will go into 87 times. 77. We annex another 0. We bring it down. Uh-oh, are we seeing a pattern here? How many times will 11 go into? We're back to 30 again. So in this decimal, we could keep going on and on and on, dividing into 30, dividing into, dividing into 80, dividing into 30, dividing into 80, dividing into 30. It's going to be 0.27, 27, 27, 27, 27. So in this answer, 3 11ths equals 0.27. Both digits are repeating. So we put our line over both the digits because both of them are repeating in this decimal. So I wanted you to understand that in some answers, there may be just one digit repeating. In other answers, it may be the whole quotient that is repeating, okay? So I wanted you to see that. And I also wanted you to understand that when we're talking about till the decimal terminates, that means until it goes to 0, but there's sometimes that cannot happen, and that is when you would have to write your answer with your line over whatever digit is the repeating decimal, okay? All right, so let's go ahead and look at section 1. And our directions say, change these fractions to repeating decimals. Notice the repeating pattern when 9 is the denominator. All right, so we have 1/9, or 1 divided by 9. 1 divided by 9. All right, so how many times will 9 go into 10? 1. 1 times 9 is 9. 10 minus 9 is 1. Annex is 0, bring it down. How many times will 9 go into 10? 1. 1 times. So y'all see right here what's going to keep on going on? So our answer is 0.1, and the 1 is repeating. Okay, so that is how we would write our answer. Next we have 2/9, or 2 divided by 9. 9 will go into 20 2 times. 9 times 2 is 18. 20 minus 18 is 2. We annex the 0. Bring it down. 9 will go into 20 2 times. 9 times 2 is 18. Y'all see it already? It's repeating already. So 2/9 equals 0.2 with the line over it. 2 is repeating. 4/9. Y'all notice something right here? We divided 9 by 1, and 1 was our repeating decimal. We just divided, or we divided 1 by 9, and 1 was our repeating decimal. We divided 2 by 9, and 2 was our repeating decimal. Let's divide 4 by 9 and see what happens. 4 divided by 9. And next are zeros. 9 will go into 40. Decimal point up there 3 times. No, sorry, 4 times. 9 times 4 is 36. We subtract. We have 4. And next is 0. Bring it down. 9 will go into 40 how many times? 4 times. 9 times 4 is 36. We subtract. 4. Y'all see the pattern already? So what's our repeating decimal here when we divided 4 by 9? It was 4. So 4 over 9 equals 0.4, and 4 repeats. It's kind of cool with the number 9, isn't it? Let's do 5/9 and see what happens. 5 divided by 9. Just by our pattern, 1 divided by 9 equals 0.1 repeating decimal. 2 divided by 9 equals 0.2 repeating decimal. 4 divided by 9 equals 0.4 repeating decimal. 5 divided by 9 is probably going to be 0.5 repeating decimal. So 5 divided by 9. Put a next to 0 decimal point in the quotient. 9 will go into 50. 4. Why do I keep doing that, guys? 5 times. 9 times 5 is 45. We subtract. 10 minus 5 is 5. And x is 0. Bring it down. 9 will go into 50 how many times? 5 times. 9 times 5 is 45. Bring it down, and it's just going to keep being the same, so we just keep annexing our zeros. So 5/9 equals 0.5. 5 is the repeating decimal. Okay? What about 7 divided by 9? Do we need to work it out, or do you think we have that figured out? 7 divided by 9 is going to be 0.7 with the repeating decimal, and then 8 divided by 9 is going to be 0.8 with the repeating decimal. Now it says to notice the repeating pattern when 9 is the denominator. So we can't expect that to happen every time, but when 9 is the denominator, you can expect that. Okay? Section 2. Mark under the incorrect fraction and decimal pairs. So if you look at the top there, you'll see some more fraction decimal equivalents. 1/3 is 0.3. ... or 0.3 with the line. We're doing 0.3 with the line. 2/3 is 0.6 with the line. 1/6 is 0.16 with the repeating decimal over the 6. And 5/6 is 0.83 with the repeating decimal over the 3. Okay? So letter A, mark under the incorrect fraction and decimal parts. So 3/4 equals 0.75. That is correct. 1.6 equals 0.133. Or 1/6 equals 0.133. Is that correct? Look at the top. No, it is not. So we will color that one in. 2/3 equals 0.6. Is that correct? Look at your box at the top. Nope, because it's 0.6 with the repeating decimal. So that should have a repeating line on it. 1/3 equals 0.3. That is correct. 2/5 equals 0.4. That is correct. Letter F, 1/8 equals 0.125. Gonna have to work that one out. That one is not at the top. So what is it? 0.18. Goodness. 1/8. So 1 divided by 8. So work it out real quick. 8 will go into 10 2 times. 8 times 2 is 16. 10 minus 16 is 6. We bring down the 0. And next is 0. 8 will go into 60. 8 times 7 is 56. Subtract. That would be 4. Well, I'm the only one up in here doing this video. And the Google was out in the kitchen talking. Go figure. Let me close this door. That is just weird. Okay, so annex another 0. Bring it down. And 8 will go into 40 5 times. So 0.275. And it says 1.8 equals 1.25. Well, in the midst of Google talking and kind of blowing my mind there, I did something wrong on the board. That is a correct decimal, guys. Letter G, 5/8 equals 0.626. Not correct. 1/4 equals 0.25. It is correct. 1/5 equals 0.2. It is correct. 1/2 equals 0.5. It is correct. Letter K, 5/6 equals 0.83. Repeating. That is not correct. Just the 3 repeats on that. 3/5 equals 0.3, and the 3 repeats on that. That is not correct. 7/8 equals 0.875. That is correct. 3/11 equals 0.27, and the 7 is repeating. Not correct. 1/7 equals 0.142857. And that one is correct. If you were to divide that all the way out, that would be correct. And then the crazy thing is, all of that repeats. Okay, so that would be a fun one to do. Y'all might want to, if you just like these decimal things, go ahead and work that one out. You would like that. Round to the nearest tenth, 0.78 rounds to the hundredths place is our looker digit. It's 5 or above, so we'll add 1 to our tenths place, so it would be 0.8. 1.29. The hundredths place is our looker digit. It's 5 or above, so we'll add 1 to our tenths place, so that is 1.3. 0.34. The hundredths place, the 4, is our looker digit. It's less than 5, so we'll just leave our tenths place alone, and it's 0.3. 1.56. The 6 is our looker digit. That's in the hundredths place. It's 5 or above, so we'll add 1 to our tenths place, so it'll be 1.6. 2.45. The 5 is our looker digit. So that's 5 or above, so we will add 1 to our tenths place, so that will be 2.5. Go ahead and turn your books over to the back side. Round to the nearest hundredth, so 0.476 rounded to the nearest hundredth. The thousandths place is our looker digit now, so that is 5 or above. So we will add 1 to our hundredths place, and it'll be 0.48. 1.029, the thousandths place is our looker digit because we're rounding to the hundredths. It's 5 or above, so we will add 1 to our hundredths place, so it will be 1.03. 4.572, the thousandths place is our looker digit. It is a 2. It's less than 5, so we'll just leave our hundredths place alone, and it's 4.57. 0.125. The 5 in the thousandths place is our looker digit. We're rounding to the hundredths. That looker digit is 5 or above, so we will add 1 to our hundredths place digit, and it'll be 0.13. Next, we have 4.007. The thousandths place, the 7 is our looker digit. It is 5 or above, so we will add 1 to our hundredths place, so it will be 4.01. Rounding to the nearest thousandth, we have 0.4032. So if we're rounding to the nearest thousandths, the 10,000th place will be our looker digit, okay? So in 0.4032, the 2 is our looker digit. It's less than 5, so we'll just leave our thousandths place alone, and it will be 0.403. In 0.7285, the 5 is in the 10,000ths place. That's our looker digit. It's 5 or above, so we will add 1 to the thousandths place, and it will be 0.729. Okay? In 0.6293, the 3 is in the 10,000ths place. That's our looker digit. It's less than 5, so we're just going to leave our digit in the thousandths place alone, so it will be 0.629. Next, we have 1.4847. The 7 is in the 10,000ths place. it's 5 or above, so we will add 1 to the digit in the thousandths place, and that will make it 1.485. Letter E, 3.0002. The 2 is in the 10,000ths place. That is our looker digit. It's less than 5, so we will just leave our thousandths place alone, and it'll be 3.000. Section 6, we are going to round to the nearest whole number. 14 and 3/5. It rounds to 15. It's closer to the next whole number. You can think of it like you can think 1/5, 2/5, 3/5, 4/5, 5/5 would be the whole. So just see how close that fraction would be to the whole. If it's closer to the whole, the 5/5, then it's going to round up. The whole number will round up to the next number. We have 9 and 10/17. So it'd be like having 1/17, 2/17, 3/17, 4/17, 5/17, and 10/17 is definitely going to round that 9 up to 10. Then we have 21 and 5/7. Think of it as 1/7, 2/7, 3/7, 4/7, 5/7. So that is definitely going to be 22. Then we have 5 and 2/9. So that would be 1/9, 2/9, 3/9, 4/9, 5/9, all the way till I got up to 9/9. Then it would switch over to the next whole number. But that's very close to the 5 end of it, so that number is just going to stay 5. Y'all understand? Making sense? And then for 19 and 13/21, that would be like having 1/21, 2/21, 3/21, and so on and so on and so on. So that 19 would round up to the next whole number, and that would be 20. Fill in the blank with the correct number. 1/2 pound. How many ounces are in a pound? 16. So half a pound would be 8 ounces. 3/4 of a bushel. How many bushel are in a peck? 4. So 3/4 of that would be 3. You would have 1/4, 2/4, 3/4. Okay. So 3/4 would be 3. And then 25 feet is 8.5 yards. From feet to yards, you're going smaller to larger. So you would divide 25 by 3 because there's 3 feet in a yard, and you would get 8.5. Okay. All right. So just a heads up, a lot of that rounding to the nearest tenths, hundredths, thousandths is on your will be coming up on your final exam. Okay. All right. So that's our math for today.